Hello viewers, you're welcome to the second part of this video in this playlist, Circle Geometry. If you haven't watched the first video, kindly watch the first video. So this video we are going to be learning more theorems and solving more examples in Circle Theorem. Without further delay, let's start the video. Here we are going to look at the second theorem, the next theorem. Now that theorem states that angles in the same segment are equal. So I'm going to break it down for you. Angles subtended by the two ends of a chord at the circumference are the same. Now if you have it this way, you will get the concept. Let me break it down. If you have a circle drawn and you have chord drawn, and that line is not going to pass through the center, the name of that line is called chord. So chord is going to have two ends, isn't it? Now we have two ends for the chord here, and the two ends is also part of the circumference. So if you draw a straight line from one end and you draw another straight line from the other end, joining the two, and you make sure that the two lines come in contact at the circumference, it's going to form angle. You are forming angle with the two ends at the circumference. So you have an angle here. Now you can form as many angles as possible. That is what the theorem is saying. Now you have this angle, and let's say you form another angle using the two ends again. The angle that you are forming with the two ends of that chord will always be the same, regardless of where you are forming it. So far it is from the two ends of that chord and it is being formed at the circumference. You are going to get the same value. Now let's say in an example, in an exam, they might not draw the chord for you. So let's have our chord. Let me remove the chord. So you can see that we have 2 points on the circumference, and all these angles that is being formed are from the same point. These angles are from the same point. So that is what you need to understand in this theorem. So don't just look for chord. What you need to look after is the 2 points that is forming angle. Are those angles coming from the same point? So once they are coming from the same point, it means that those angles are the same. And another thing is, students might be looking for a simple and straightforward question. At times, most time, the theorem will be twisted, the question will be twisted, whereby you have a change in the direction. Some will be looking for something like this, while in your exam they might just rotate it for you. That's another thing that you need to know about this theorem. This theorem is simple and is straightforward. Let's apply this theorem in solving question. Let's have an example. Let's have this example. Find the value of x in the diagram. Carefully observe this diagram. We want to find the value of x in this diagram. Now if you look at this diagram very well, before we start solving it, just observe something here. We have BC. BC is a chord, DC is a chord, AB is also a chord, AC is also a chord, and BD is also a chord. But if you notice one thing, two ends of this chord form two angles, angle X and angle BAC, this angle. So I'm just showing you the picture. Another thing you need to observe in this question here is this symbol. This symbol is telling you that triangle ABC, this triangle over here, is a right angle triangle, and this angle is 90 degrees. So let's see how to solve it. Now solution. We know that triangle ABC is a right angle triangle, and for right angle triangle, if you know one interior angles from the, if you know one interior angle, you can know the third angle from trigonometry. You can go ahead and watch my video on trigonometry. I have a playlist for trigonometry. Now you have angle A, which means this angle will automatically be what? 90 minus 30 degrees. This is coming from the concept of trigonometry, some of the interior angles of a triangle. And if you're applying that in right angle triangle, if you know one angle, the other angle will be 90 degrees minus 30 degrees. I've done that in trigonometry. So which makes this angle 60 degrees. Now from our theorem, we're supposed to know that angle A, this angle will be the same thing with this x. Why? Angle in the same segment. this chord divide this circle to two segments. Now the two ends form two angles, angle here and angle here. So the angle will be the same thing. So x is equals to 60 degrees. You might not see a straightforward question where they will give you the value of x here and they will now ask you this. Most time they might want to twist a question and apply another thing in a certain question. You see how we apply trigonometry here. And let's look at simple example. Here we go. We have a simple example. I expect you to solve this. This is quite simple. Now in the question, find the value of x in the diagram. Is obviously what? The value of x will also 40 degrees. Now look at this point and this point. This point, if you join them together, it becomes chord, isn't it? And this point and this point, it forms angle here, and it also forms angle here. So which means that these angles are in the same segment. So x is also 40 degrees. Let's look at the next theorem, which is theorem 3. That theorem is angle subtended by a chord at the center of a circle is twice that at the circumference. Angle subtended by a chord at the center of a circle is twice that at the circumference. What is the meaning of this? Let's have a circle. Let's have the center of a circle. Now if you have two, let's say you join two parts of that circle together and that line is not passing through the center, the name of that line will be chord. Now the two end of that chord, this is the two end of that chord. Now if you remove that chord again and you try to join the two ends with the center of the circle, an angle will be subtended at the center, will be formed at the center. Now this theorem is not telling you that whenever you have something like this, at the same point, a line is extruded from the same point and it forms another angle at the circumference. And the same point as well, line is protruded and angles are formed at the circumference from these two same points. Now all these angles will be the same thing, angle at the same segment. Angle at the same segment. Now if that same point now happens to form angle at the center, at the middle of your circle, the angle that is formed at the circumference and the angle at the center has a relationship. And what is that relationship? 2 times the angle at the circumference. So which means the angle at the center will be twice the one at the circumference. That is what this theorem is saying. Let me explain the concept again. If you pick 2 points at your circumference and at the same 2 points angles are being formed, the second theorem is being applied here, which says angle in the same segment are equal. That is why this one is theta, this one is theta, this one is theta, because all these angles are being formed by 2 points, 2 same points. Now that same point, if another angle is now being formed at the center, it means that the angle that is formed at the center will be twice that one that is being formed at the circumference. Another thing you need to know is, so you might see it in a rotated form like I'm showing you. You might see it in a rotated form. Just get the concept. And let's have a simple example. The example is in the diagram below. O is the center of the circle and angle BDC is 50 degrees. We have been told that this O is the center of the circle and angle BDC is 50 degrees. Just follow this. This is BDC, which means this angle is 50 degrees. You can all see it in the question. An angle OCA. So which means this angle is 35 degrees. And find the value of x y, and z. We have to find the value of x, this angle, y, this angle, and z, this angle. So we want to find the value. Let's see how to apply our theorem. Solution. Now we have our diagram. Now we have x here. Now carefully observe this diagram. You can see that this x will be equals to 50 degrees, which means BDC, angle BDC will be the same thing as what angle BAC. Why? Just look at these 2 points. An angle is formed at the center, 2 angles is formed at the circumference. So angle in the same segment are equal. So obviously we have our angle BAC is equals to BDC and is equals to x, which is 50 degrees. You can see the 2 points here. The next thing is we should know that an angle is being formed at the center, which is angle BOC, and that angle is y. Now if you pick any one of these, is either you pick this x or you pick this 50 degrees. So x is BAC, y this 50 degrees is BDC. Now angle BDC, the angle that is formed at the center will be twice that of the one that is formed at the circumference. So which means that 2 multiplied by 50 degrees, 2 multiplied by BDC will give us y. That is what is written here. So angle at the center is twice that at the circumference. Now obviously y will now be what? 2 multiplied by 50 degrees. And 2 multiplied by 50 degrees will give us 100 degrees. So we've gotten the value of y. The next thing is we want to find the value of z. Now z is a bit technical, but simple. It's not even technical, it's simple. Now let's look at z. Let's see how to find the value of z. I want you to observe something here. We've known the value of y here. We've known the value of x here. Now to find z, what we need to do is we need to find this angle. This angle. If we can find this angle, it will give us a clue on how to find z. What do I mean? Now to find this angle, this is angle at a point. So since we have known the value of y, we can know this angle. To know that angle, we know that angle BOC is equals to 360 degrees minus 100 degrees. So angle at a point, sum of angle at a point is 360 degrees. If this angle is this angle plus this angle will give us 360 degrees. So this angle will now be 360 degrees minus this angle, which is 100. So that gives us 260 degrees. Here we go. Now look at this diagram very well. We can see that this diagram is a polygon. And what is the name of this polygon? Let's count the number of sides of this polygon. We have the first side 1, second side 2, third side 3, and the fourth side 4. We can see that this is a quadrilateral. Not just quadrilateral, this is a convex quadrilateral, not concave. This is convex quadrilateral, and is also irregular. Quadrilateral is a four-sided polygon. I have a playlist on Euclidean geometry where you can learn all this. Now, what is the property of quadrilateral? Sum of the interior angles of a quadrilateral is equals to 360 degrees. So the angle inside, interior angles, if you add everything together, you get 360 degrees. That is what you have done here. So obviously, you are going to get 260 degrees, which happens to be the angle outside, plus z plus x plus 35 degrees. That is the interior angles. If you add everything together, you get 360 degrees. When you substitute the value of x, so we have 260 degrees plus z plus 50 degrees plus 35, and when you add everything together, when you add all the angles together, apart from the one that you don't know, which is z. So you are going to get 50 plus 35, that's 85. 85 plus 260 degrees, so we are going to get 345 degree. So that is why we have z plus 345 degree. The next thing is to find the value of z plus 345 degree. We know that when we add all these angles together, we are getting 360 degrees. So that makes it z plus 345 is equals to 360 degree. Finally, our z will be 360 degree minus 345 degree, and that is 15 degree. The third example in the diagram, O is the center of circle ADBCE. This is a circle ADBCE. If the angle 290 degrees was subtended by radius OB, where's our radius OB? OB and OC, they subtend angle 290 degree. Now look at the 290 degree that is given to us is outside like this. Calculate the value of W, X, Y, and Z. So we want to calculate the value of W, X, Y, and Z. We have our diagram here. To find the value of W, X, Y, and Z, let's quickly observe something here. We see that W, look at this point. Every angle that is being formed here are from these 2 points. 2 points. So which means that Y, X, and W, X, Y angle form the same segment. So it means that if we know X, we can use it to find the value of Y, since everything here is the same. So what we just need to do is to find the value of Z. And don't forget, we can use angle at a point to find the value of Z. This question is very simple. Now Z plus 290 degree will give us 360 degree angle at the point. So if you add this angle plus this angle, what are you going to get? 360 degrees. So we can find the value of this angle Z. So Z will be 360 degree minus 290 degree, and that will give us 70 degrees. So we have gotten the angle that is subtended at the center, which is 70 degrees. Now using the theorem, is twice the one at the circumference. So which means 2 multiplied by X should give us Z. Let me come again. 2X should give us Z. Now if you solve that, you are going to get what? X divide both sides by 2. X will now give us Z over 2. What is the value of Z? 70 degree divided by 2, and that is 35 degree. So if this one is 35 degree, this one will be 70 degree. Same. So we have gotten the value of X. So let's find the value of Y and W. Now X is equals to Y and is equals to W, which is 35 degree, angle in the same segment. We can see that solving question in circle geometry using circle theorem is actually simple. Circle geometry is just like a puzzle you are solving using some guideline. And what is the guideline? All the theorems that you know, they are just a weapon that you will use to solve question like this. Unlike algebra that you can just solve, this one is just giving you a guideline. You just have to picture and visualize the theorem that you will use to solve the question. Thank you very much. If you haven't subscribed to my channel, kindly subscribe to my channel, like my video, share my video, and see you in the next video. The next video is going to be the continuation of this video, which is we are going to learn more theorems. Thanks for watching this video. Stay blessed. See you in the next video. Bye for now.